Today, I receive a special guest. Some of you might already know who he is. He is famous in the Ethereum community for having created a lot of developer tools like the Burner wallet. I'm always curious to know what is his next invention, and I'm super happy because I can finally ask him all the questions I want. So without further ado, let me introduce Austin Griffith. Welcome, Austin.
What's up? Thanks for having me. This is awesome.
Yeah,
I've seen a few of your videos, so it's cool. We kind of probably cross-inspire each other with our different videos.
Yeah, absolutely. Like I reached out to you on Twitter, and I figured out like you actually already knew my channel. I was like, wow,
Of
Austin,
course.
channel. Yeah. So Austin, like, how long have you been in blockchain, and how you got into Ethereum?
So let's see, probably 2 years now about. I started by building games and silly things, trying to just figure out where kind of I could do something that no one else could do. And I created this ship game called Galleass. It's galleass.io, and it's you kind of sail around and catch fish, and you commit reveal, and it's like this hand-painted world. But the onboarding was really bad. No one could use it because they had to have ETH and they had to have MetaMask. And so that taught me that we needed better onboarding and user experience. And I kind of focused on that for a while and learned about meta transactions and learned how we could have burner wallets. And, we can kind of just create an address for someone on page load. They can sign a message, and then we can pay for the, gas for them.
Okay, wow. So that was like your first experiment with Ethereum.
Yeah.
Like I guess like early when Ethereum was still like a bit rough on the edges.
Well, yeah, I mean, I'm kind of a late comer to it in terms of like I didn't get there as early as most people. I was like doing DevOps and working with Docker, and I was kind of down the Docker rabbit hole when Ethereum came out, so I missed it. But yeah, it was kind of like building games, then building tools to focus on UX, and now it's more like building tools for developers to build more things. Like basically focused on prototyping. The eth.build and Scaffold ETH are both these sort of prototyping, either educational or prototyping, like learning how to build a dApp. What I want is for you or anyone to be able to just clone a repo for a weekend hackathon and be able to just quickly build a product, build something on Ethereum.
Yeah, and I think you've been pretty prolific because you build many different developer tools.
Yeah, it's kind of like that. My mentality is just to smash out a bunch of prototypes and see what sticks. And yeah, a couple prototypes have been like gotten a little usage, and a burner wallet is a good example. Then kind of someone from the community, David Myhall, like rebuilds it, cleans up the code. A lot of my code is pretty messy because I'm just like quickly trying to stick things together. And then once something is proven, like the burner wallet was, then someone rebuilds it and makes it more extensible and easier for everyone else to take that code and extend.
So for those who don't know, what is the burner wallet in a nutshell, what it is?
Okay, so the burner wallet is think of it like a web wallet where your private key that normally would be stored in MetaMask or a hardware wallet is actually right in the local storage of your browser, and it's used to sign transactions and sometimes meta transactions. But then we take that experience and we run it on a sidechain. So you have quick, the sidechain's cDai, so you have quick, cheap block times. It bridges to Ethereum, so you can withdraw and deposit into it, and then it's just like very, very fast transactions. So like I can send money around very cheaply, very quickly on the sidechain, and then bridge it back to mainnet Ethereum. But the point is, anybody can just like, I don't have a paper wallet laying around, but you can scan a paper wallet, you can receive a link. The onboarding is basically instantaneous. You just go to a website and you have money, and then you can click send and scan someone else's QR code and send them money. So it's about that experience. It's about that ease of use. It's about being able to just like instantly onboard someone into something and let them use it first. Then once they get it and they understand that like, okay, there are some security trade-offs here. This is a network of validators. Like if I move over to Ethereum, move over to DAI, then I can get a stable coin that's also, protected by proof of work or some more extravagant consensus mechanism.
Yeah, I remember when this came out, I think it was really popular at meetups when people were trying different like blockchain stuff. Then people were using this to like send to each other some crypto, and yeah, it was pretty cool. And so yeah, I mean, that was a project that got a lot of traction. And today you are here to talk about another project, which is called eth.build.
Yeah, word. Yeah. So eth.build is, I could probably just like share my screen for a little bit. You want me to do that?
Yeah, you're allowed.
Okay, cool, cool. Yeah, so eth.build, here it is. It's sort of like this, it's kind of like a visual playground. I can grab this, I can, pull this in here. I can type some code, and then we could, compile that contract by putting it in here and giving it a name. Let's see, can I click this? Yeah, there we go.
So it looks like sort of like visual builder for developing smart contract.
Yep. Yeah, it's not just for developing smart contracts, but kind of just like prototyping all of Web3 stuff. There we got it to compile. And what happens is when we compile it, we get an ABI out of it. So I could maybe make a uint like count, right, equals 42. If I compile that, then yeah, I get the ABI and the bytecode, and technically we could, bring in a transaction and push that bytecode into the data field, and that would deploy this as a contract to whatever chain we are hooked up to. So it's a very visual programming language where you can kind of learn Web3 concepts, basically hash functions, key pairs, encryption, blockchain transactions, distributed ledger, and how the consensus mechanism works there or doesn't work, and then kind of proof of work and the Byzantine generals onto smart contracts and gas and meta transactions and all sorts of stuff.
So it seems like it works in real time. Like you change one part, and then if there is an action, then you will see the result right away. So it's a little bit like if you define a set of functions with input and output, and it just works.
Yep, absolutely. You basically, like if we bring in a hash function, it has like an input and an output. And what's happening is this code right here is on every render. So it's using LightGraph. Let me see, I can point to it. LightGraph, a library that does over the top of it and then plug in a bunch of Web3 components to it. But basically what it's doing is that every time it's rendering, it's taking whatever is over here. You can see it changing over here, right? And rendering it on the other side. It's easier if we even like look at this as a blocky or something. So we can see like each time I type, we see that change on that side, right? But what's cool is you could say this is, let's say the hash of Alice is a 64 character. We could just plug it in here, and now we have that. We can use that as a private key, right? And once we have that as a private key, then we can see the address is derived from that, right? So it could be, instead of Alice, we could say that's Bob, right? And we can show that it's deterministic by, I can type Alice back in and we get the same picture. I can type Bob back in and we get the same picture. What's cool now is now we have these two accounts that could sort of send value back and forth, right? We have Alice here and we have Bob here, and we could bring in like a distributed ledger, right? And then we could have, like objects for transactions. We could say to from Alice, right? And then we could plug that into our ledger and send that along. And what's neat there is then now we can go look at, oh, the value 0. What did I do there? I think there's a bug here with decimals. Yeah, let's just set that to 0. There we go. So now we have 10. So now we could say, we could go get a balance function, right? And we can plug, watch this, we'll plug Alice into the, oh, no. We got to plug Alice's address in to the balance function. And now we can call that, and it's going to hopefully go find that her balance is not working. Huh, I wonder what I did wrong there. But what the thing I learned here is you have this function that comes off of this box, and you're calling this function every time this is run. And that's what, like if we bring in a blockchain, if you wanted to get the block number from a specific chain, oh, we don't want to go from GUI, there's mainnet, right? And so every few seconds, we'll see this timer trigger this button that goes out to mainnet and gets the block number, right? So we kind of have this block, and then we have this this node, and then we have another node that comes off of it that's actually a function. It was an interesting paradigm to get to when I started building the tool, because I had no idea how this was going to work. But then it totally makes sense. It's like, oh, a function comes off of this, and you plug arguments into the function and then can call it. Or if it's a contract, let's see, can we do this? Let's take our ABI. Do we still have our ABI? No, we don't. Okay. If we had an ABI, we could drop it in.
Awesome. So thank you for this demo. So now our task is to invest in the cDai contract of Compound. So for those of you who don't know what is Compound is a very famous DeFi protocol where you can lend and borrow ERC-20 tokens. And so what we're going to do is provide some liquidity to Compound by investing some DAI. And so we're going to get some interest thanks to that. So we're not going to do this on mainnet because we don't want to spend our money. But we're going to do this on the Kovan testnet. So on Kovan, you have the contract of DAI, which is deployed, and also cDai. So we all set. So for that, we will need to first get some Kovan Ether, and then with the Kovan Ether, we're going to get some DAI by using the Oasis interface of MakerDAO. And once we have the DAI, then we can finally invest the DAI in the cDai contract. And we're going to do all of this with eth.build.
It'll be a lot to put together. Let's just kind of poke at it and see how far we get. I don't know if we'll get that far. The eth.build is more like poking at things rather than building a full, but let's just see. Let's see how far we get. So basically you said we want to get on Kovan. Yeah. And if we back up just a little bit, we probably want to generate some kind of account. Is that right? So yeah. If I just pull up some button, I can kind of just like generate private keys. So let's just hide the private key so no one can see it for a little bit. I bet we'll expose it at some point, but let's pick out a cool blocky. Okay, that blue guy. All right, blue guy is going to be our guy. So what we need now is to send this address some Kovan ETH. I'll send it to you there. But also we probably, let's plug in Kovan as our blockchain, and then let's get the block number so we know that we're talking to Kovan. Boop. Okay, there we go. So Kovan is on block, what, 18,743,000. Okay, and we also want to know the balance of this account that we just created. So we'll plug its address in here, and we'll just have that always asking, and it's 0. So we need to get some Kovan ETH to this dude. How does the Kovan testnet work?
Yeah.
Or the faucet work?
So we just need to go to the faucet. So you can Google Kovan faucet, and it's probably the first link. And we just input our address, and it's going to send us some Ether.
Okay, it's asking me to log in with my GitHub address, and now it's asking me for the Kovan address, and I'm pasting it, and I'm sending it, and it says it's on the way. Okay, and here is the Etherscan transaction. Okay, so here, oh, look at that, we already have it. Look at, we have a balance.
Amazing.
There we go, there we go. Okay, so we have, what, 1 Kovan ETH? Okay.
Yeah.
So now we want to, you said you want to swap the ETH into DAI?
Yeah, so we're going to open a vault on the MakerDAO system. So we send our ETH to MakerDAO.
Oh, open a vault, not even swap it on Uniswap. You want to basically collateralize the ETH and get DAI back. Is that right?
Yeah.
Oh, wow.
Yeah.
Okay. So what's that contract look like on Kovan? How do we get to it?
So actually, maybe that for this part, it's easier to use the interface of MakerDAO, because I think the process for doing this is actually quite complex. You don't have just one function, but you have several.
Okay.
It's possible to use what they call, they have a proxy contract that group different operations in just one function, but I'm not super familiar with this. So maybe if we just use the interface, it's easier.
Okay.
So
what's the
So it's you go to, can you Google Oasis Oasis Maker DAO? Oasis app, yeah, that one. And then the trick, so this is for mainnet, but
oh yeah, but we have a private key here. What will I do? Put this private key into MetaMask? They're not going to let us,
oh yeah, okay.
right?
Mhm.
I mean, we could do that, but maybe maybe we should just dive into the cDai just to show. So let's just say we could swap tokens. I don't know if you want to send this guy some Coven DAI. That might be an easier shortcut. But let's dive in and look at the compound contract, right? So if I go, do we have? Let's see. I think you sent me a.
Yeah, okay.
Yeah, here we go. Okay, so cDai address is this right here on Coven though, right? It's not. I think maybe this is the cDai address on mainnet.
No, that's on mainnet. My bad. Yeah, I mean that works.
Let's poke at it. Let's poke at it. That's fine.
Yeah.
That's fine.
Yeah.
Let's poke at it. Okay, so what you did is you sent me this JSON file, and you can't see it yet, but let me do a file drop. Okay, and I'll drag in the JSON. Did you see how that changed there? And if we look at it, it's basically everything that was in that file that you sent me. So we see addresses and stuff, but what we want to do is parse that. So if we parse that, that'll be an object that we can look at, and we can reason with it a little bit better. So let's see, you had this DAI address, which is what we were just looking at, what we just Googled, but then there's also this ABI, right? So this is kind of like when you're going to interface with an Ethereum smart contract, there's these artifacts, right? And you'll have this ABI and this address, and what can we do with that? So if we bring up a contract and we plug this ABI into it, watch this, boop. So then we have all of these functions that we can call on this contract, and we have the address of it. And if we just bring up a blockchain and we say, we just don't set anything here, and we look at that block number, just like we did on Covan, but this time, I don't know why, it thinks it's Gwei because it has this specific, we see that we are on block 10 million and some, right? So that's the main net, and we'll plug that in here. Okay, so now we have our contracts. Do you remember what the function is that you would call to lock up DAI to get cDai?
Yeah, so that's the mint function.
Mint, okay, so
yeah,
there we go. Wow, so that's basically it. You pass in the, oh, I bet you have to approve first, huh?
Oh yeah.
I bet you do an approve, and you approve this contract to take a certain amount, and then I bet you call mint and it takes it from that. Okay, so we probably won't be able to do that unless we could send some cDai into this, into some,
not on mainnet.
I mean, why not on mainnet? It's not that much money. Let's see. Take a mnemonic, take a password. Let's see. Can I do this? This is gonna be wild. Okay, so I'm gonna put in a password here. You can't see it, right? Okay, and then I'm gonna plug that into a mnemonic, and I'm gonna plug that into a private key, and that's gonna give me an address. Now, if I go look at the balance of this address, it actually is some ETH in it, but we're looking at DAI, right? We want to know the DAI contract. So then if I do a balance of on the DAI contract, plugging in this guy's address, oh, that's not right. Something's not right there. Let's try ERC20. This is like, it's very much a prototype.
But also, like you have some predefined ABI in eth.build.
Yes, exactly. Whenever you want to extend something, you sort of grab that ABI that we were just looking at and you put it into eth.build, but you customize it, and it gives you this nice little box that just has the functions you need. Let's try that one more time, see if we can get this guy's balance. I'm thinking he has DAI. Okay, so he has 14 DAI. Okay,
wow, it's amazing.
So now he needs to what? Approve.
Need to approve cDai.
Approve the contract itself, right? So I call approve. Yeah, okay. So the spender is actually the cDai address, right? Is this guy?
Yeah.
And then the amount would be a number, and we'll say $5. And you'll need to remember to probably take that two-way, right?
Yeah.
All right, now this is really interesting. What's going to come out of this, right? It's a box. This was like an aha moment for me when building eth.build. What this is actually the bytecode of the transaction, right? So what we need to do is bring in a wallet, and we'll plug, let's plug our blockchain in. Yep. Let's plug our private key in. Don't look. To address will be the guy, it's the cDai contract, right? First, we're going to approve that cDai, and it won't have any value. And the data will be this stuff, right? That hex stuff. And let's give it a gas limit of, say, what, 200,000 maybe? Oh, we're going to have to set the gas price. Let's get into this wallet. Get out of here. Okay. We're going to have to set the gas. Oh, it already is 40.04. Look at that. It's doing gas for us by checking the network.
Wow.
Isn't that cool?
Yeah, it's really
we want it fast. Okay, so let's get back out to here. We're assuming that the wallet is going to handle the gas for us. We'll do 200,000 for our gas limit. All right, let's put in a button. We're watching for a transaction hash to happen. Are we doing this on mainnet? We're doing this on mainnet. Okay, here we go. Didn't go. Oh, it did go. It did go. Okay, so we have a mainnet transaction out there. It is in the transaction pool.
Cool.
We could talk to our local node here and see what's going on, but basically I think what we're waiting for is a receipt to come back from mainnet. Let's grab this guy's address and go to
I think we got it.
Scan. Did it go through? Did we get? Oh yeah, there we go. So we just made a mainnet transaction from an account with an 8-character mnemonic on mainnet. This is how you prototype. Okay, so now what we're assuming is the cDai contract is approved to take 5 of our DAI, right? Yeah. So now we want to call the mint function, and we're going to mint that same amount, right? That 5 DAI. And this is going to give us some bytecode. Now what we do is we take that bytecode and replace it up here. Now, do we need to send in ETH? Let me think here. No, we're only sending in DAI. So we still don't want to send any value here. We still send it to them. Basically, what we're going to do is call a function on the cDai contract that tells them to come take our $5 that we approved them for. They're going to lock up that 5 DAI and give us back some cDai.
Exactly.
And then, okay. So before we do that, then let's go grab our balance of cDai and prove that it's still 0, right? Because we'll want to see it change to, let's see, balance of this guy in cDai should be 0. Okay, here we go. Okay, so let's see. We have the mint function. That's the bytecode, right? So that's the function call. Oh, by the way, while we're here, let's do this. If we take the hash of mint, right? Oh, and it's going to be mint amount, which is going to be like a UNT250. This isn't going to work. No, it's just mint amount. Let's try this. It did not work. Darn it. So let's see. What is the, that's the format. That's the format. We got it. Check it out. So if I do that string and I do a hash of it, look how this lines up. That's the function call, right? The first 8 characters there is the same thing there. That fun little side quest there. Okay, so we're calling mint and we're sending it this amount, which if we take that and go to from way, we're going to get 1 or 5 DAI. Okay, I think we're ready. I think we have the bytecode. We have the data in there. It's time to make another transaction. Do I just hit that button? Yep, there we go. Okay, another transaction is going out. We can go to a disinterested third-party Etherscan and ask them what we're up to. Let's see what happens.
Exciting times.
It is. It really is. There we go. So it looks like it went all the way through. Do we have a balance? No, we still don't have a balance. Let's see, what's the status?
But now I think we need to change something to see the balance of cDai.
Oh, I thought that's what this was. Status is true. I thought that's what this guy's doing. Balance of, right?
Yeah, but now it's balance of on the contract of cDai.
Oh, that's something else. Oh, it's a different contract? I thought that's this guy right here. Isn't this guy the cDai contract?
Yeah, but I mean, because before we're checking balance off on the DAI contract, but now if you want to see our cDai balance, it's balance off of the cDai contract.
Yeah, I did. That's what this guy is here. So
Okay.
this is balance of DAI. So here's DAI and balance of, and our DAI actually did not go down. So we did something wrong somewhere along the way.
Austin,
Let's see.
I think we just hacked Compound. We found it
I don't doubt it. Yeah. Let's check our allowance to make sure our approve worked, right? Isn't there an allowance function? There we go. So maybe you need to allow someone else. I feel like, so this is exactly what we're doing, is we're like poking at contracts, seeing how they work. This is what like eth.build is for, right? Like you can teach someone what a hash function is and do a lot of educational stuff, and I could switch over and draw some things here. But eventually it really, for me, it comes down to this moment of like viscerally poking at this contract and saying, what is happening here? Why is this not working? And so if I get the allowance and I get the owner, which would be me, right? This guy.
Oh, the allowance is for delegated transfer of your cDai. So that's something else. That's after you.
Aha, we need to set an allowance in DAI, of course. Duh. So it's here, right? We need this approve function. We were using the wrong approve function.
Oh,
yes.
Okay.
There we go. That's totally right. Okay, so now the spender will be the DAI contract and the value will be this. So a different approve to a different contract. So it's funny, like right now that it actually is like the cDai contract is approved to move $5 of our cDai, right?
Yeah, that's not useful.
Okay,
yeah.
cDai is there, value is there, approve is there. All right, let's try again. Plug this into the data field and send a transaction. Yeah. Mainnet transactions with private keys and 8-character mnemonics.
Is it the first time you do mainnet?
There we go. Okay, so now this should work, right? We should have an allowance. We could check the allowance right now, but I'm not even going to do it. I'm just going to move this into here. Now we're saying, so we called approve on the DAI contract to allow. Now we're going to call mint on the cDai contract, and it's going to go to the DAI contract and transfer some of our 5 and prove that all works. Let's see if it goes. There we go. Okay, in motion. Now here's our balance of cDai. Oh, there was a failure. Status is false. I wonder what we did. Let's see. 5 of that.
Can we see what's the allowance of DAI for the cDai contract?
Yep.
Yeah.
That would be this right here, right? So we want allowance. So the owner is us, right? Our address. And the spender is the DAI contract address.
cDai.
cDai contract. Yes, of course. Sorry. And there we go. Yeah. So it's 5 ETH, right? Not ETH, but 5 times 10 to the 18. So it is approved. So we know that much. Are you sure that you call mint to? Let's see. We could go look at the contract, couldn't we?
Yeah.
Let's see. If I copy this and I go to Etherscan, I bet their contract is going to be here. So we could go look at the code and say, what does mint do, right?
I wonder if it's a prime of unit, because I think at some point you need a conversion 5 two-way, but I think when we get the balance of DAI, this is the balance in a elementary unit of DAI. So it's not like,
okay.
I don't think it's
so
5.
Try plugging 5 in here.
Yeah.
So it just is a 5.
Yeah,
let's try it
without two-way. Yeah.
There we go. Okay. So we're just going to call a mint with 5.
Yeah.
Interesting. I feel like you want the decimals there, because then you could never do, I don't know. Let's see what happens. Can we see us making a call on this contract? We can probably see the transactions, right?
Yeah.
Who are we?
4 minutes.
I don't see us in that list. I bet we are, though. Oh man, I need those errors to be clearer. Yeah. We definitely are getting. It is failing.
It's still failing.
Could it be running out of gas? Try 400,000. I really think it's two-way here. Let's put that back in just for a second to try a little bit more gas, and then maybe I'll try to copy the message that we're getting there. All right, let's try another one. We could even just plug this hash in here, and it should tell us.
Yeah.
Does that transaction look right? Let's see. Oh, there it was again. I wasn't able to copy it. Darn it. Okay. Well, I think we may have hit a wall here in terms of. Oh man, am I paying $3 per transaction right now? Good Lord. Let's see. It reverted, but it doesn't tell us exactly why. It only cost 17 cents. That's okay.
Damn.
I don't know what it is. It's something with the mint, something. Yeah, we're close here, but we're very close to getting it. But this is kind of like where I go for prototyping. And then if you want, I can move over to Scaffold ETH real quick just to show that. Like once you've poked around at eth.build, I say to move over to Scaffold ETH. It's basically like this repo. Can you see that there? Yeah, it's like a repo in GitHub that allows you to you just clone down this code, and there's a speed run here. But it has a blockchain powered by Buidler. It has Create React app powered by Ethers and Uniswap from Paul Berg created Create ETH app. But basically, you do this, like you clone it, you CD into it, you do an install, you start up your chain, and you deploy your contracts. And it starts out with smart contracts. See that there? So it starts out with smart contract, and you change a spelling error, and you deploy your contracts again, and your app will hot reload in the front end. So it's a really quick way to sort of like iterate on building a product. I could dive into it, but I think we've covered a bunch of stuff already. I don't know how long this is supposed to go for, but we got a bunch, but I think we kind of hit a roadblock here with cDai. I'm not exactly sure what's going on.
Yeah, but this was absolutely fascinating. You know, like when you were like pulling this box and all this direction, like I was pretending to understand everything. I was like, yeah, that makes sense. No, but
it's a lot of fun to play with. Yeah.
Yeah, absolutely. I think what I want to do after this video is I want to go back to it and try out simple stuff. Like first, without the blockchain, maybe try to compute some hash, and then like try to play with a connector. And but it looks really fun. And yeah, I'm so sorry because I know I really challenge you a lot. Like first, when I reached out to you to do this video, you thought we would do something simple, and then I came out with this crazy idea with this compound.
we hit a roadblock. I'm not sure what was going on there. I don't know why it didn't let us mint that. We had the 5, we had gas. Like, could I have run out of gas? What's my balance? No, because then it would say run out of gas. I'm not sure what the roadblock was, but yeah, this is Web3 programming. This is how it works, right? There's a contract out there in the sky, and we know kind of the AVI, and we kind of poke at it, figure out how to get it to work, and then one day cDai comes back, and we know we did it right.
I think it's also the pleasure of Ethereum. Like, let's say you write a function in Node.js. Like, if you execute this function successful, you're not gonna like jump and say, "Oh, I executed my function."
Right.
But Ethereum, when you execute your transaction on mainnet, I mean, you call up all your buddy, you go drinking. I don't know, you do something special.
I still get goosebumps when I send money from a command line. It's funny how it works, but yeah, it's a powerful technology, and we're like just at the beginning of it, and it's really exciting.
So people, if you want to have fun with the eth.build, like you go to the website and try to poke around and try to interact with contract on Ethereum, how people can reach out to you and basically keep up with all the different projects?
Yeah, I think at Austin Griffith is the best way to find me on Twitter. AustinGriffith. Yep. So, yep. That's probably, eth.build, Scaffold ETH, at Austin Griffith. Hit me in the DMs. I can help you out with anything.
I'll put the link.
eth.build, yeah, if you actually just click on eth.build, it'll take you to a site that has like learning material. It starts with hash functions and key pairs and goes through it. So just right there on the eth.build website, you should be able to kind of like, a new person should be able to get some context for how Ethereum works.
Awesome. Thank you, Austin, for showing us all this stuff. I wish you to keep producing some awesome tools for us. And I'll talk to you soon.
Awesome. Thank you so much for having me. Thanks for having me. See
Bye,
you.
Austin.